Hello all, welcome to online lecture series on Laplace transforms. I have a question for you. How do you evaluate this integral? Integral 0 to infinity e power 3t into t sine 2t dt. Think? Do you feel difficult to evaluate this integral? Here in this lecture, we are going to learn a very easy technique to evaluate such integrals. This technique is Laplace transform technique. So in this lecture, we'll see how Laplace transform technique is applied to evaluate improper integrals from 0 to infinity. Let us start now. Let us start with this example. Evaluate integral 0 to infinity t times e power minus 3t dt using Laplace transform. We know that the Laplace transform of a function f of t is given by L of f of t is equals to integral 0 to infinity e power minus st into f of t dt. This we all know, this is by the definition of Laplace transform. Now consider the given integral 0 to infinity t times e power minus 3t dt, and compare this integral with the integral in the Laplace transform. Integral 0 to infinity here and even integral 0 to infinity here also. We have f of t here, and in place of f of t we have t here, and we have e power minus st in this integral, and in place of e power minus st we have e power minus 3t, that is in place of s we have 3 here. So we note that the given integral is integral 0 to infinity t into e power minus st, where s is equal to 3. Now what is integral 0 to infinity t into e power minus st? It is equals to L of t. That is L of t. What is L of t? 1 by s square. Therefore, integral 0 to infinity e power minus st into t dt is equals to 1 by s square. Now put s is equal to 3. What happens then? Integral 0 to infinity t into e power minus 3t dt is 1 by 3 square, because s is equals to 3, which is equals to 9. Therefore, the value of integral 0 to infinity t e power minus 3t dt is equals to 1 by 9. So, the integral is evaluated. See how easy it is to evaluate these integrals using Laplace transform technique. So, now let us go to the next problem. Evaluate integral 0 to infinity e power 3t into t sine 2t dt. Compare with the definition of Laplace transform. Here also we have integral 0 to infinity e power 3t into f of t dt. So if we compare this with the integral in the Laplace definition of Laplace transform, we note that the given integral is of the form integral 0 to infinity e power minus st into t sine 2t dt. What is s here? S is equals to minus 3. If we put s is equals to minus 3 here, we get e power 3t. So s is minus 3 in this case. Now if we compare this integral with the integral in the definition of Laplace transform, in place of f of t, we have here t sine 2t. Therefore, this integral is equals to Laplace transform of t sine 2t. Now we can evaluate Laplace transform of t sine 2t by applying the properties. What is L of t into f of t? L of t into f of t is minus d by ds of L of f of t. So L of t into sine 2t is minus d by ds of L of sine 2t. And L of sine 2t is 2 by s square plus 4. So this is minus d by ds of 2 by s square plus 4. Just finding its derivative, we get Laplace transform of t into sine t. Derivative of 1 by s square plus 4 is minus 1 by s square plus 4 whole square into internal derivative, that is derivative of s square plus 4 is 2s. So minus and minus becomes plus, 2 into 2s becomes 4s by s square plus 4 whole square. Therefore, integral 0 to infinity e power minus st into t sine 2t dt is equals to 4s by s square plus 4 whole square. Now, To obtain the required integral, in place of s we put minus 3. So putting s is equals to minus 3 in this equation, we get integral 0 to infinity e power minus of minus 3t, that is e power 3t, t into sine 2t dt is equals to 4 times minus 3 by minus 3 whole square, that is 9, plus 4 whole square, that is equals to minus 12 by 13 square is 169. Therefore, the value of this integral is equals to minus 12 by 169. So, in this way, we can apply Laplace transform technique to evaluate the improper integrals whose lower limit is 0 and upper limit is infinity by comparing the given integral with the definition of Laplace transform of the function. Let us see another example. Using Laplace transform, evaluate integral 0 to infinity sine 2t by t dt. So again take the definition of Laplace transform and write the given integral 0 to infinity sine 2t by t as integral 0 to infinity e power minus st sine 2t by t dt. What can we take s here? Because there is no e power exponential term here, and because we are writing exponential term, we take s is equals to 0. So that e power 0 becomes 1, and we again have integral 0 to infinity sine 2t by t. So the given integral is integral 0 to infinity e power minus st into sine 2t by t dt, where s is equal to 0. Now look at these two integrals, the integral in the definition of Laplace transform and this integral. So if we compare, f of t is here sine 2t by t. Therefore, by this definition, this integral is equal to L of f of t, that is L of sine 2t by t. And L of sine 2t by t can be evaluated using this property L of f of t by t, which is equal to integral s to infinity L of f of t ds. So and hence L of sine 2t by t is integral s to infinity L of sine 2t ds. That is integral s to infinity L of sine 2t is 2 by s square plus 4 ds. And integral of 1 by s square plus 4 is 1 by 2 tan inverse s by 2. 2 and 2 gets cancelled. So we have tan inverse s by 2 within the limits s to infinity. Now if we substitute the limits, we have tan inverse infinity minus tan inverse s by 2. Tan inverse infinity is pi by 2 minus tan inverse s by 2, which is equals to cot inverse s by 2, because tan inverse x plus cot inverse x is always equals to pi by 2. Therefore, the given integral 0 to infinity e power minus st into sine 2t by t dt is cot inverse of s by 2. Now we put s is equals to 0. Then we get integral 0 to infinity sine 2t by t dt is cot inverse of 0. Taking s is equal to 0 here. Cot inverse of 0 is pi by 2. And hence the value of integral 0 to infinity sine 2t by t dt is equal to pi by 2. See how easily we can evaluate such integrals using Laplace transform technique. One can enjoy this technique. One more example in this direction. Using Laplace transform, show that integral 0 to infinity t square into e power minus 4t sine 2t dt is 11 by 500. So now you may be familiar with identifying what is s and what is f of t. What is s in this case? S is 4 because we have e power minus 4t, and f of t is obviously t square into sine 2t. So let us quickly go into its solution. Take the definition of Laplace transform and write the given integral 0 to infinity t square e power minus 4t sine 2t dt as integral 0 to infinity e power minus st t square sine 2t dt, where s is equal to 4 because we have e power minus 4t here. Now when we compare this definition with the integral in Laplace transform, this is equal to L of f of t, and in place of f of t we have t square sine 2t. Therefore this integral is equals to L of t square sine 2t. Now to evaluate L of t square sine 2t, we need to apply L of t power n into f of t formula, which is minus 1 whole power n d power n by ds power n of L of f of t. Because here n is equal to 2, we get d square by ds square of L of f of t, that is L of sine 2t. L of sine 2t is 2 by s square plus 4. So we need to differentiate 2 by s square plus 4 twice. So first if we differentiate one time, then we get d by ds of differentiating for the first time. Derivative of 1 by s square plus 4 is minus 1 by s square plus 4 whole square into 2s. Multiplying we get minus 4s by s square plus 4 whole square. Now let us again differentiate this with respect to x using u by v formula. What is derivative of u by v? It is v into derivative of u minus u into derivative of v by v square. Here u is s and v is s square plus 4 whole square. 4 can be taken outside being constant. So now v into, that is s square plus 4 whole square, into derivative of u, that is derivative of s, is 1, minus u into, that is s into derivative of v, derivative of s square plus 4 whole square, is 2 into s square plus 4 into derivative of s square plus 4 is 2s, by v square, that is s square plus 4 whole square is s square plus 4 whole power 4. Now you can see that s square plus 4 is common in the numerator, so we can take one s square plus 4 common and we can cancel with the s square plus 4 in the denominator. Then we get minus 4 times, because 1 s square plus 4 is cancelled from this, we remain with s square plus 4 minus 2 into 2s into s, that is minus 4s square. This gives 4 minus 4 into 4 minus s square minus 4s square is minus 3s square by s square plus 4 whole cube. Therefore, the integral is equals to minus 4 times 4 minus 3s square by s square plus 4 whole cube. Now put s is equal to 4 to obtain the value of the required integral. So taking s is equal to 4, we get integral 0 to infinity e power minus 4t into t square sin 2t dt is equals to minus 4 into 4 minus 3 into 4 square by 4 square is 16 plus 4 whole cube, that is minus 4 times 4 minus 3 into 4 square is 16, that is 48. 4 minus 48 is minus 44 by 16 plus 4 is 20 whole cube. That is equals to 4 into 44 is 176 by 8000. Cancelling with 16, both the numerator and denominator, we get 16 goes 11 times here and 500 times in the denominator. So we get 11 by 500. Therefore, integral 0 to infinity e power minus 4t into t square sin 2t dt is equals to 11 by 500. So now you apply this technique of Laplace transform to evaluate these integrals. Integral 0 to infinity e power minus 4t into cos 3t dt. Here s is 4 and f of t is cos 3t. Now if you compare this integral with the integral in Laplace transform definition, this is nothing but L of cos 3t with s is equal to 4. So first write what is L of cos 3t and then finally substitute s is equal to 4. The next one is integral 0 to infinity e power minus 3t into sin t dt. S is 3, f of t is t sin t. And in the third one, integral 0 to infinity t cube e power minus t sin t dt. S is 1 here and f of t is t cube into sin t. L of t cube into sin t is minus d cube by ds cube of L of sin t. Differentiate L of sin t 3 times. And finally you have integral 0 to infinity e power minus t sin square t by t. Here s is 1 and f of t is sin square t by t. Therefore, this integral is equal to L of sin square t by t with s is equal to 1. Write sin square t as 1 minus cos 2t by 2 by t. So now apply L of f of t by t formula. Finally replace s with 1. So try to solve all these problems. If you have any doubts, please contact me. Thank you for watching this video. Keep learning.